Alright, so this is lesson 2 in this unit, and we're going to be using substitution to solve a system, and it's the first of our algebraic method of solving an equation. This is our second method. Remember, we just did graphing. That was our first method. The algebraic methods are more accurate, so let's start practicing.
Objectives. I can solve systems of equations by using substitution. I can solve real-world problems involving systems of equations.
Alright, so here's some vocabulary words, just telling you what substitution means. So pause the video, write this down, read it, and make sure you understand it. So pause it now. Alright, like I said, we already have one method in our tool bag of strategies for solving a system of equation, which is graphing. And sometimes it's not easy to solve a system of equations by graphing, so when we can't do that, we have to use algebra. Woo! Okay, so here's our first example. We're going to use substitution to solve this. So what we're going to do is if you look here, this equation up here is solved for y, the top one is. So what we're going to do is we're just going to substitute. We're going to take this value right here, 3x, and we're going to replace y down here with 3x because y is the same as 3x. So as always, when I do substitution, I rewrite the problem, and when I'm going to substitute, which is my y, I replace it with the parentheses. And inside that parentheses is going to go my value for y. Then all I have is simple equation to solve. Of course, it would help if I made this a negative 21 instead of a negative 2x. So all I have to do is use my distributive property. And then I'm wanting to change that. I'm just not wanting to write 21 at all. Alright, I combine my like terms. These two terms are alike because they both share an x. So what makes them the same, the x, I keep the same, and I do the arithmetic with the numbers in front. There's no number in front of x, but I know there's an implied 1 there because I have 1x, and 1 plus 6 is 7. So then I bring down my 21. Whenever I have a number in front of a variable, it means multiplication. They're being multiplied together. So to undo that, I do the opposite, which is divide. So my x is negative 3. Negative divided by positive is positive. But I am not done there. I only have part of my answer. I have my x coordinate. If I have two variables, I got to find two solutions. I find my x and I find my y. But all I have to do is take this value for y here and substitute in this value for x. So 3 times negative 3 is negative 9, so my y is negative 9. So this is my order of pair here, 3, negative 3, negative 9. Alright, so here's our next problem. Not as easy as the last one. Basically, you're going to use substitution when you have a variable with a coefficient of a positive 1 or negative 1. And you're going to look, and if you look at these, I have a 1 in front of my x here, a 5 in front of my y, a 3 in front of my x in the second equation, and a negative 2. I want to solve for the one that has the y in front of it. The 1 in front of it. So to get that x by itself, I have to move this over. So that leaves me with x equals, when I move it to the opposite side, it takes the opposite sign. And I got distracted by somebody walking in the door. It's negative 5y, and I have a minus 3. So now this is solved for x. So what I'm going to do is I'm going to take my other equation. You always plug it in or substitute it in the other equation. So I'm going to plug it in for x here. So remember, when I substitute in, I take that variable, I make a parentheses, I keep everything else the same, and I'm going to substitute this value in the parentheses. From there, I'm just going to distribute, and negative times positive.
I'm walking this way.
Alright, so next I have to combine my like terms. So that gives me negative 17y minus 9 equals 8. Now I have a two-step equation to solve. I'm just going to add 9, and I'm going to move it over here. Negative 17y equals 17, and I have to divide by negative 17. So that gives me my y is equal to negative 1. And now I can take this value for y. That's my answer right here, negative 1 from an ordered pair, and I can plug it in for y here. So my x is equal to negative 5 times negative 1 minus 3. So it's equal to 5 minus 3, so my x is 2. So that's my ordered pair. And my solution, where my x is 2 and my y is negative 1. Okay, here's a bunch for you to try. Why don't you practice the first one, see if you can get it, and if you can, restart the video and check your answer with mine. Alright, here's my answer for the first one. Hopefully we have the same thing. If you're good to go, why don't you go ahead and try the next one, then restart the video when you're done. Alright, so I got negative 1, negative 5 for my solution. One last one for you to try. Remember the first two were already solved for a variable, so you're going to have to figure out which variable to solve, and you've got sort of two ways to go, which either way you're going to get the same answer. So try number 3, and then when you're ready to restart, check your problem with mine. Alright, hopefully we got the same answer for the last one. Our solution was 2, 0. So if we didn't, ask me about it tomorrow and we'll talk about it then. Alright, now that you've done those examples, let's try this example here. First of all, it's not too bad because we already have one equation solved for y. So all we do is, like always, take the other equation, and we're going to take this 6x minus, and with substitution, we're substituting in for the y, 3x plus 2. So we're substituting that in, so I make a parentheses and I put that value in there, 3x plus 2. Now all I have to do is distribute. So I have 6x and negative 2 times 3x is 6x, and negative 2 times positive 2 is negative 4. I have a 6x and a minus 6x. So they both have an x, but 6 minus 6 is 0, so I have 0 x's, so they cancel each other out. And I'm left with negative 4 equals negative 4. So what does that mean when I have negative 4 equals negative 4? Well, is that a true statement? And yes, it is, because negative 4 and negative 4, they are equal to each other. It means when you have a true statement is you have infinite solutions. When you graph those, if you put them in slope-intercept and graph them, it's going to be the same line. And that means you have a consistent and dependent system. If I had got a false statement when I solved it, if I'd have got like 2 equal to 0, well, 2 does not equal to 0, so that's a false statement. So whenever you get a false statement, that means there is no solutions. If you graph them, you have parallel lines. And parallel lines, no solutions, means an inconsistent system. Alright, let's try a word problem. I know everybody loves a word problem. So here's our problem here, our situation. So a student has some $1 bills and $5 bills in his wallet. He has a total of 15 bills. What are they worth? They are worth $47. We know what they're worth. We need to find out how many of each type he has. So what we're going to do is we're going to set up a system of equations. First of all, we're going to let x equal our number of $1 bills. And we're going to let y equal our number of $5 bills. And we're going to take that information and we are going to make equations. So we have 15 bills total. So our number of $1 bills plus our number of $5 bills has to be 15 bills. Also, a $1 bill is worth $1. So $1 times how many $1 bills we have, and $5 times how many $5 bills we have has to equal how much money we have, which is 47. Alright, so I'm going to use substitution to solve this system of equations. So I'm going to take this first equation here and I'm going to solve it for x. And you can do x or y, whichever one you want to. And all I'm going to do is subtract y from each side or move y to the opposite side. And when I do that, I get 15 minus y. Then I'm going to substitute. I'm going to take everywhere I had an x and I'm going to put a parentheses for that x. And inside that parentheses, I'm going to substitute in the value I know to be my x. And then, well, when I distribute and I combine my two like terms, they both have a y, and 5 minus 1 is 4. So I have 15 plus 4y equals 47. Alright, so 15 plus 4y equals 47, two-step equation. I subtract 15 from each side or move 15 to the opposite side, and when I do that, it has the opposite sign. And I get 32, and I divide by 4. So y equals 8, and y is my number of $5 bills. So if I have 8 $5 bills, that means I have to have 7 $1 bills. And let's see if that works out. So if I have 8 $5 bills, that's going to give me what? $40. And if I have 7 $1 bills, that's going to give me $7. And guess what? If I add those two together, that gives me $47 bills. It's $47, not dollar bills, and that's how much money I should have. All right, one more example. All right, this is another word problem. Why don't you read this problem and see if you can come up with how many World Series the Reds and the Yankees won each. So pause the video, see if you can solve this, and then restart and see what you got and see if we come up with the same answer. So pause the video now. Well, here's what I got. The Yankees must have won 26 World Series, whereas the Reds have only won 5 World Series. So a little bit one-sided there, right? Yankees are coming out ahead of the Reds. So, okay, that is it for solving systems of equations by substitution. Our next lesson will be about solving systems by our next algebraic method, which will be elimination.